Okay, we're going to go back and do a little bit of review. Up till now, you've done solving linear inequalities in one variable from chapter 4.1. And those are solved very much in the same way that you solve linear equations. Again, this is in one variable, so you're going to end up with your solution being able to be graphed on a number line. So in the first one, A, the one variable is y. Second one, B, the one variable is x. And in the third one, C, the one variable is x again. So we're going to go through and solve those, and then we'll talk about to the right what it looks like graphing-wise to solve linear inequalities in two variables. Okay, so just like in solving a linear equation, you subtract 2 using the subtraction property of equality. You're left with negative 5y is greater than or equal to negative 15. You divide both sides by negative 5. Now here's where it's a little different than an equation. When you divide or multiply by a negative, the inequality symbol flips. So you have y becomes less than or equal to from greater than or equal to, and a negative divided by a negative is a positive 3. There's your solution. Now if you want to graph it, it's going to be a closed point above 3. Any values that are solutions will be less than, the values will be less than 3. So we're going to go to the left here to all the values less than 3. Checking it. 0 is less than 3, so 0 is less than or equal to 3. That's true, so we've graphed it correctly. Letter B is an AND compound inequality. That's where you see the variable will be sandwiched in the middle when we're done. We subtract 5 from the middle, 5 from the right, and 5 from the left. We end up with 4 and negative 5 is negative 1 is less than 5 and negative 5 is 0, so we are left with x. 7 minus 5, or 7 plus negative 5 is 2, less than 2. This is your inequality. Negative 1 is less than x is less than 2. And that's going to be an AND compound inequality with an open point above negative 1, open point above 2, and all the values in between will be solutions. We can quickly check that 0 is underneath that segment, and so therefore it should be true. Negative 1 is less than 0, that's true, and 0 is less than 2, that's also true. So we have graphed correctly. All right, let's look at the next one. Letter C is an OR compound inequality. On the first one, negative x is greater than 4. You need to get rid of the negative in front of the x, so we're going to divide by negative 1. So x, now when you divide by a negative, your inequality symbol flips. X is less than negative 4. Or, oops, let's move that down. Let's put the or down below. X is less than negative 4. The other side is negative 2x minus 6 is less than 0, so we add 6 to both sides. And we're left using the addition property of equality, negative 2x is less than 6. We divide both sides by negative 2. When you divide by a negative, your inequality symbol will flip. So negative 2x divided by negative 2 is x. Less than becomes greater than. 6 divided by negative 2 is negative 3. So your inequality is x is less than negative 4, or, got to have that word or, x is greater than negative 3. Both of these are open points, so an open point at negative 4, open point at negative 3. And or compound inequalities are raised in opposite directions. Let's check that we're right. Pick a value that's less than negative 4, that's negative 5, that falls under the raise, so that's correct. Pick a value that's greater than negative 3, well that's negative 2, so that's correct. So our inequality and our graph are all correct. So some key things to remember when solving linear inequalities in one variable is that you'll have one variable, and whenever you have one variable, it's going to be solved in much the same way as a linear equation. The only difference you'll see is that if you multiply or divide by a negative, then the inequality symbol will flip or reverse. And then the other thing to consider is the type of graph you'll have in a linear inequality in one variable. It will be a number line graph. And that takes us to the next part, which is solving linear inequalities in two variables, which is chapter 4.2. Now, depending on how your equation is written is how you'll graph the line. And this is a review. So you can graph your lines in two ways. You can you could do a table of values. There's actually 3 ways, but we're going to either use, in this portion, we're going to either use slope-intercept form or standard form. X plus 2y, two variables, x and y, is less than 6. Since it's in standard form, we're going to use x and y intercepts. An x-intercept will lie on the x-axis, a y-intercept will lie on the y-axis. Meaning that for the x value, the y-coordinate was 0, you can see that right there. And for the y-intercept, it's on the y-axis, so the x-coordinate will be 0. Let's find our x-intercept, so it's going to be x plus 2 times, well, y is going to be 0, it's less than 6, so x is less than 6. Now, I know we typically, when we do equations, it's equal to, so it's a little bit easier, but it's still going to be 6, 0, because the x value is going to be 6 and the y value is going to be 0. So we're going to plot that, 6, 0, and we're going to write the ordered pair 6, 0. And then we're going to do the y-intercept, so it's going to be 0 for the x value, plus 2y, less than 6. So 2y is less than 6. Using the division property of equality, divide by 2. Y is less than 3. Now, that ordered pair then is going to be 0, 3, because it's a y point on the y-axis, so it's going to be 0 and a y value, so 0, 3. And we're going to label it 0, 3. Now, we're going to connect those 2 points. Here's where you have to be careful with. When it's less than, it is a broken line. So we're going to go ahead and draw a broken line. Okay, the broken line's only one part of it. Here's where it starts to get different. In an equation, it would always be a solid line, but if it's less than or greater than, then it's going to be a broken line or a dashed line. And if it's less than or equal to or greater than or equal to, then it will be a solid line, because the points that are on this line will not be solutions for this problem. If it were a solid line, then the points on the line would be a solution. Now, 0, 0, here's the next difference. 0, 0 is not on that line, so we can use it. What we're trying to find out is all of the solutions. As you know, you don't just have one solution in inequality, you have many, many solutions. For instance, if I were to plot a point, once I know which side my solutions are on, then those solutions would work out. So let's choose 0, 0, let's plug it back in. X is 0 for the x value, plus 2 times 0, because y is 0, is less than 6. 0 plus 2 times 0, which is 0, is less than 6. You have to look at that and determine whether that's true. So 0 is less than 6. So if it's true, include 0, 0 as a solution. And since it is true, we're going to include 0, 0. So we're going to shade, and it's going to be everything on this side of the line into infinity. So let me show you what that means. So there's many, many, many points. 0, 0 is one of them that's the solution. But let's choose a different color. And let's go ahead and choose 1, 1, because 1, 1 would be a solution as well. So 1, 1 would also be a solution. So let's plug this in and see if it works. So we're going to check 1, 1. So we plug in x is 1 plus y is 1. 2 times 1 is less than 6. 1 plus 2 times 1 is 2 is less than 6. 1 plus 2 is 3 is less than 6. It's true. So we know that 1, 1 is also a solution. You could do that on many or an infinite number of solutions. If you pick something out here, let me get the eraser. If you pick something out in here, however, those would not be solutions. But just to make this a little clearer, I'm going to go ahead and I'm going to continue this line. So let's continue that line out and get rid of that little arrow right there. There. Now you can see that the line is going all the way across into infinity. Okay, so the difference between solving linear inequalities in one variable versus linear inequalities in two variables is that you use a number line graph for one variable and you use a coordinate graph for two variables. Another difference, actually a similarity, let's look at that first. A similarity is that you have many solutions for one variable and you also have many ordered pair solutions for two variables. All right, now we're going to move on to some more examples. Now in this example that you're seeing here, we're going to continue to solve linear inequalities in two variables. This is y is less than or equal to 3x minus 1. There's two variables, y and x. However, this one is written in slope intercept form. So this one is written in slope intercept form. And when it's written in slope-intercept form, you use the slope triangle to graph your line. So B, the y-intercept, is -1, so let's go ahead and graph -1. And then it goes up, it's positively sloping because m is 3, so we go up 1, 2, 3, and over 1. 1, 2, 3, and over 1. I'm going to go back down 1, 2, 1, 2, 3, and over 1. And 1, 2, 3, and over 1 to the left. Okay, this is going to be a solid line because it's got the equal to. So there's your line. It looks like it went through -1, but it went through 0, 0, but it doesn't quite. Now this solid line, any points that fall on this line are solutions. So this is just another way to graph a line, which you already know how to do. We're going to go ahead and check it using 0, 0, because you were close, but you didn't quite go through 0, 0. So we're going to put a little point there, 0, 0. It's just to the left of the line. All right, so we are going to go ahead and we are going to plug in, we're choosing 0, 0, we're going to plug it into this equation here. So y is 0. Greater than or equal to 3 times x is 0, there's your x, minus 1. So 0 is greater than or equal to, 3 times 0 is 0 minus 1. 0 is greater than or equal to -1. 0 is greater than or equal to -1, so this is true, which means that you need a shade on the side that includes 0, 0. Now we're going to pick a different point, just so we can see that it does work. We'll pick this point at -1, 0. So we're going to pick this point right here, -1, 0, and then we'll check out. So we're going to check out -1, 0 to see if it is in fact a solution. So if we substitute it into that equation, y is 0, it's greater than or equal to 3 times -1 minus 1. Your -1 is your x, there's your x. So 0 is greater than or equal to -3, and I'm going to go plus a -1. 0 is greater than or equal to -4, that is true. So this -1, 0 is a solution. And you can see that on the graph it is a solution. Okay, I want you to look at this problem, which is on page 182, number 8. 2x plus 5y is greater than or equal to -2. You're going to go, since it's in standard form, ax plus by is equal to c, you're going to use x and y intercepts, and then I want you to go ahead and check your work. Turn it back on after you're done. Okay, you can see that for the x-intercept, we had 2x plus 5 times 0, because on an x-intercept, you have x and then a 0 value for the y. It's greater than or equal to -2. So 2x is plus 0 is greater than or equal to -2. You can divide both sides by 2. So 2x divided by 2 is x, -2 divided by 2 is -1, x is greater than or equal to -1. So -1, 0, plotted here, is your x-coordinate. Then your y-intercept is going to be 2 times 0, because your x will be 0, and your y value. And then plus 5y is greater than or equal to -2. 5y is greater than or equal to -2. Divide both sides by 5. You end up with y is greater than or equal to -2/5. So it's 0, -2/5 right there. It's a solid line because this has an equal to sign on it, your inequality. You would try 0, 0, so you plug in 0, 0. 0, 0 is not on the line, so you can use 0, 0. And you go ahead and plug in 0, 0, 2 times x being 0, plus 5 times 0 is greater than or equal to -2. 0 is greater than or equal to -2, true, so you're going to shade to include 0, 0.